In this video, let's practice on dividing polynomials using long division approach. To help make this process clear, we are going to work on polynomial divisions and a regular number division simultaneously. We'll have them right next to each other so that you can easily compare each step. This parallel approach will really highlight the similarities between the two. Let's start with a regular division problem with two numbers. Let's say we divide 4369 by 14. For long division, we set it up by writing 4369 under a division symbol, and then the divisor 14 to the left of it. So let's follow that exact same structure for our polynomials. So we have 2x cubic plus 5x squared plus 3x minus 4. So this dividend is placed under the division symbol, and the divisor x plus 5 goes over to the left. Okay, now for the numbers. Our divisor 14 has two digits. So we look at the first two digits of our dividend, 43. We need to figure out what number, when multiplied by 14, will get us as close as possible to 43 without going over. Let's try 3. 3 times 14 is 42. So we write 42 right under the 43. And then we subtract, we get a remainder of 1. All right, let's jump back to our polynomials. Our divisor x plus 5 has two terms. So we focus on the first two terms of our dividend, 2x cubic plus 5x squared. Just like what we did with the numbers, we need to find a term here so that we multiply this term by our divisor x plus 5. We'll have a leading term that matches this 2x cubic, so we can subtract and eliminate it. It's not too tricky to see that if we multiply the x plus 5 by 2x squared and then multiply this 2x squared by this x plus 5, we get a term of 2x squared times x, which is 2x cubic, then plus another term, 2x squared times 5, which is 10x squared. So don't forget we need to distribute this 2x squared across both terms. Okay, so this gives us 2x cubic plus 10x squared. Then as what we've done to the numbers, we need to subtract these two expressions. 2x cubic minus 2x cubic is going to be 0. 5x squared minus 10x squared is negative 5x squared. All right, back to our numbers. After getting a remainder of 1, the next step is to bring down the next digit from the dividend, which is 6. So we write 6 next to 1, giving us 16. Now we do exactly the same thing with our polynomials. We bring down the next term from the dividend, which is this plus 3x. We write it next to our remainder, plus 3x. Now we repeat the process with our new number, 16. We ask ourselves again, what is the largest whole number that when multiplied by 14 gets us as close as possible to 16 without going over? In this case, we know that the number is 1. So 1 times 14 is 14 here. And then we subtract them, we get a remainder of 2. All right, for the polynomials, we also repeat the same process that we'll need to find a term when multiplied by this x plus 5 will give us a leading term that matches to this, minus 5x squared. We know this term would be minus 5x. So with minus 5x times x, we get minus 5x squared. And minus 5x times 5, we get minus 25x. And then let's subtract them. Minus 5x squared minus itself give us 0. And 3x minus negative 25x. So here is 3x minus negative 20x. This will give us actually 28x. So here is 28x. Now we just repeat the process until we have finished working on the last digit of the number or the last term of the polynomial. For the number, we bring down the last digit, 9, down here. So we have 29. We know that 14 multiplied by 2 is 28. Subtracting them, we have 29 minus 28, which is 1. So dividing 4369 by 14 gives us a quotient of 312 with a remainder of 1. So 321 is the quotient. And 1 is the remainder. Now let's finish the polynomials. We bring down the last term, which is minus 4. Now we look at our current leading term, which is 28x. To get 28x, we need to multiply this x by 28. So we need 28 here. So we multiply 28 to this x. We have 28x. And we multiply this 28x to this 5. We have 140. Now we subtract these two expressions. 28x minus 28x is again 0. And negative 4 minus 140 give us negative 144. So we have negative 144 here. So the division of these polynomials give us a quotient of 2x squared minus 5x plus 28. So this is the quotient of this division. And the remainder is negative 144. So this is the remainder. I hope this breakdown and this analogous to number division has made polynomials long division a bit clearer to you. And if you found this helpful, please consider liking and subscribing. Of course, feel free to leave a question in the comments below.